Hello everybody and welcome to Campus 101 exam curriculum series. My name is Dr. Peter and today we're going to be looking at reactions. Now what is a reaction? A reaction is when compounds, elements interact chemically to form products. Now what I'm going to talk to you today about is the rate of reactions. In chemistry there are some physical processes, there are some physical conditions that affect the rate of reaction. So what are these factors that affect the rate of reaction? I'm going to tell you four important ones that I want you to always remember. The first thing is, let's say substance A and B react to give us substance C and D. Now, the factors that are going to affect the rate of this reaction, when I mean the rate of reaction, that means the formation of the product. The factors that will affect it are the concentration of A and B. So we can just call that concentration of what? Of substrate. That's the first factor that affects it. If I take away A from this, the reaction cannot continue because there's no A to react with B to form C and D. Obviously, so the concentration, the amount of A and B present will determine a lot about the rate of the reaction. 2 is the pH of the medium. There are some reactions that are favored by acidic medium. That means when the pH is low. And there are some reactions that are highly favored when the pH is high, or when the pH is alkaline or basic. Understand? So the pH determines it. So if a reaction is favored by a low pH and I increase the pH, that of course the rate of the reaction is going to reduce. Understand? So that's a very important factor that also affects the rate of a chemical reaction. Now let's talk about another factor that affects a chemical reaction. Now when we talk about solids and liquids, we talk of concentration. But when we talk about gases, we talk of pressure. So for gaseous system, I repeat, only for gaseous system, the pressure of the system would also affect the rate of reaction. For example, let's take a very common example. When hydrogen gas reacts with chloride to form HCl. Now, the concentration of this, and we will not talk of concentration when we talk about gases, we only talk about pressure. So the pressure of this system will determine where the reaction is going to be favored. Understand? And here now there are 2 moles. There's 1 mole of hydrogen, there's 1 mole of chloride, and then that means 2 moles are here in the reactant aspect of the reaction, and then there's 1 mole of HCl on this side. So the pressure is going to be altered. Don't worry, we'll talk about pressure later when we're talking in detail about the second part of our discussion today. Now, another factor that affects the rate of reactions, obviously, is what? Exactly. It is the temperature of the system. Generally, the higher the temperature, the faster the reaction. But it's not in all cases. But most times, the higher, when you increase the temperature, you increase the rate of the reactions in chemistry generally. So the temperature plays a very important role in reactions. In fact, in some reactions, we have to heat the substrates and the substrate to very high temperatures. And then with talking of temperature is another important point that we're going to talk about, because most times in chemistry we need to heat the system to a very high degree of temperature, which is expensive. We introduce what we call catalysts. Now catalysts are substances that affect the rate, that increase the rate of the reaction most times. Now if I put a catalyst here, it can alter the rate of formation of C and D. So catalyst fastens or fast forwards the reaction, you understand? Now we're playing the video at 0.1, but if you want to really prepare and you are short of time, you can increase the speed of the video you're watching now. And so that means you are putting a catalyst to your learning, you understand? So these are the factors that affect the rate of reaction. Now, next thing I'm going to talk to you about today is the principle by one famous French scientist called Le Chateliers principle. Now, Le Chateliers principle is better explained than defined. Now, let's go back to our earlier example. We said substance A reacts with substance B, and in a reversible manner. In chemistry, this is how we do reversibility, to give us C and D. Now, C and D. And now, let's say, for example, that we needed 2 molecules of A to react with 1 molecule of B to give us C and D. Let's just assume that this is the end reaction. This is the end formula of our reaction. Now, if we leave this in an isolated system, let's say this was our beaker, our glass beaker, or our conical flask that the reaction was taking place in. This system will come to equilibrium. By equilibrium, it means that as the same number as products are being formed, the products are also reacting together to form the substrates. So substrates are reacting to form products are reacting to form substrates. They're going to come to an equilibrium where the amount of formation of product is equal to the amount of formation of substrate. That is where we say the system is in what? In equilibrium. Now, if we introduce a stress into this system, and let's indicate stress by red. If we introduce a stress into this system, Le Chatelier's principle said that this system is going to alter itself to balance off the stress. For example, let's assume that as A and B are reacting to form C and D, I decide to come and take away some of the concentration of the D from the system. As I'm taking D away, what will happen? More A and B will react to form more C and D, actually to form more D, to balance off the system. In the same way, if I took away B, more C and D will react to form A and B so that the system comes to balance. It's like now you're watching on your phone. Now, if I move my paper this way, I've altered your balance. You're going to shift your phone to the right, to the left, so that you can now see it clearly. If I still move it, so now you have, by moving your phone to the right, you are doing the Chatelier's principle. You are altering your screen so that it's straight. That means you are returning it back to equilibrium. In the same way, if I move it to the right, I'm sorry I'm doing this to you, but I want you to understand. You have moved your phone again to be able to balance it so that you can see straight. In the same way, when I take away A, the equilibrium will shift to the left. When I take away D, the equilibrium will shift to the right. That's what the Chatelier's principle is saying. And it is used especially in large chemical reactions to fasten the rate of the reaction. Especially, let's assume that what we want to produce is D. If what we want to produce is D, what do you think we'll do? Exactly. We'll take away more D from, as D is formed, we'll be taking it away from the system so that more A and B will be, reacting to form C and D. Now, this principle is especially important in the herbal process. The herbal process is used in the industrial manufacture of ammonia. And if you watch the video on ammonia, you know that ammonia is a very important component and chemical used in manufacture of fertilizers, drugs, and a lot of other things. You understand? So ammonia, herbal process. Don't forget this, and don't forget what we said in Le Chatelier's principle, that the system moves to neutralize the stress that is introduced into a system that is in equilibrium. So as a means of summary, once again, we talked about factors affecting reaction. We say the concentration of the substrates, the pH, whether low or high, the pressure in gaseous system, temperature and catalyst, all affect the rate of reaction. We also talk about Le Chatelier's principle and how altering either the product or the reactant, either the substrate or the product, can affect the reaction, and the system alters to bring and neutralize the stress that is imputed into the system. So thank you for watching, and see you in the other videos.